Boom. So now we come to the point of enunciating a general formula for the gradient of a straight line given any 2 points in the straight line. Right? Notice we didn't just throw the formula at you, right? As I always do whenever possible, I try to take the time to explain stuff so that you can understand what we're talking about when we're talking about it. Because yes, the language of mathematics does get a little complicated, right? A lot of Greek letters and plus and minus and blah and blah and blah, right? But we need to understand what them things stand for and what they mean, so that we could talk and we could understand and be understood. Good? So this here is the general situation. The gradient of a straight line given any 2 points x1, y1 and x2, y2, that lie on the line is gradient m is equal to y2 minus y1 over x2 minus x1. Now it doesn't matter which point you label as x1, y1 and which point you label as x2, y2, and we will demonstrate that when we do a couple examples. Good? Excuse me. So in this case we have a positive gradient here. This is a point x1, y1. This is a point x2, y2. So the gradient will simply be y2 minus y1, here minus the y coordinates, over x2 minus x1. Same story across here. This time I put the x1, y1 on top here, and I put the x2, y2 below here. So the gradient will simply be y2 minus y1 over x2 minus x1. That is as straightforward as the formula is. Hopefully it is a lot more straightforward now, given that we would have spent some time going through the idea from before, which I hope you would have done if the topic is of some concern to you before now. Alright? So now we're going to do some live examples where we talk about finding the gradient of a line segment between any 2 points. Alright, so 2 random points. Let us start with 2 points where all the points are positive and then all the coordinates are positive, and then we mix it up. So let us say we have the point, just as we were doing in class Saturday, let me say AB. Let me say I have the point A is the point 3, 4, and B is the point 9, 13, right? And you want to find the gradient of the line joining those 2 points. Now it is, once you're familiar with the formula, it is not necessary to draw these points accurately on a graph. What I would normally do is just do something very basic. So I would say that A, 3, 4 and B, 9, 13, right? 9, 13. So we know that the gradient m is equal to y2 minus y1 over x2 minus x1. So let us, for argument's sake, say that this point here is x2, y2, and this point here is x1, y1. Alright? And this here is the line segment joining the 2 points. Alright? So we have the lettering scheme in red. So for consistency's sake, we're going to say m is equal to y2 minus y1. That will be 13 minus 4, and x2 minus x1, that will be over 9 minus 3. 13 minus 4 is still 9, 9 minus 3 is still 6. So your gradient is 9 over 6, which is equal to 3 over 2. Alright? Now, we could reverse the lettering scheme. So let us say now that, and I'm going to remove this here now. This B corresponding to this point here, and I'm going to remove this now. this A corresponding to this point here. Let us, for argument's sake, say that we have this here as x2, y2, and this here as x1, y1. Right? So in other words, you have total autonomy, total control over how you choose to label your points. Which one you put as x1, y1, and which one you put as x2, y2. Once you do that, then your only task after that is to be consistent in terms of how you label the points across here. So in this case, the gradient will now be, and I'm going in green here now, m will be equal to y2 minus y1, that will be 4 minus 13, 4 minus 13, over x2 minus x1, which would be 3 minus 9, which would be minus 9 over minus 6, which would be the same 3 over 2. Alright? So it does not matter at all, which point you label as x1, y1 and which point you label as x2, y2. Once you are consistent in terms of your coordinates, you will be safe. Now, sometimes what I would suggest is, if you absolutely need a little visual help, what you can do is write the points down next to each other. So in this case, we could say A is the point 3, 4, and B is the point 9, 13. Alright? So in that case now, you have, if you write the points down one over the other, you have the y coordinates lining up and you have the x coordinates lining up. So that the gradient will simply be 13 minus 4 divided by 9 minus 3, which is what we have in this case here. Or you can do the other way and say that the gradient will be 4 minus 13 divided by 3 minus 9, which is what we have here in green. Any way you choose to do it, the gradient will be the same, so long as you take care with your signs. So we're going to do now one now with negative coordinates, just to drive the point home a little further. Alright, so again, let us use two random points where all the coordinates are negative. So let us say we just use A, B, let me use X, Y. So let us say, no, let me use P and Q. Let us say the point P is the point minus 3, minus 8, and the point Q is the point minus 7, minus 2. Good? So in this case, we have points with all negative coordinates. Again, we could choose to draw a diagram, a little sketch, right? So this is a point P, and this is a point Q, right? So I'm going to leave the space there for when we do the different versions of the letter. So we know that the gradient is that m is equal to y2 minus y1 over x2 minus x1, right? And again, just as an aside, you could choose to use the technique where you actually write the points down, p minus 3 minus 8, and you have q here as minus 7 minus 2, right? So you write the points down side by side. So in the red scheme, we will have x1, y1 here, and x2, y2 here. So in this scheme, p is x1, y1, and q is x2, y2. In the green scheme, your p would now be x2, y2, and the q would be x1, y1. Good? So let me go with the red first. So in the red scheme, general formula, y2 minus y1 over x2 minus x1, that will be equal to, so in red we have that m will be equal to y2 minus y1, watch it now, minus 2 minus 8 all over x2 minus x1, x2 minus x1 minus 7 minus 3, which would be minus 2 plus 8 over minus 7 plus 3, which would be minus 2 plus 8 is 6, minus 7 plus 3 is minus 4, which would be equal to minus 3 over 2. So in red, we get the gradient as minus 3 over 2, which in this case would correspond to minus 2 minus 8 divided by minus 7 minus 3. So in the green scheme, we now have same story, m being equal to, in this case now, p is x2 y2 and q is x1 y1. So you then have minus 8 minus 2 minus 8 minus 2 divided by x2 minus x1 minus 3 minus 7, which will be equal to minus 8 plus 2 divided by minus 3 plus 7, which should be minus 6. Minus 3 plus 7 is 4. Minus 6 over 4, which will be equal to minus 3 over 2 as the final gradient. Right? Let me just underscore that. Minus 3 over 2. So whether the minus sign is on the 4 as in this case, or on the 6 as in this case, your final gradient is minus 3 over 2. Good? So, and again, that would correspond in this case to, it will be minus 8 minus 2 divided by minus 3 minus 7. So the signs will be flipped in terms of the difference between the red and the green, but the final answer will be the same. So that, ladies and gentlemen, is all there is to the topic of the gradients of a straight line. Alright, so you're now in a position where you could do a whole set of questions just to practice, just to get a rhythm, and then after that now we'll move on to other aspects of the straight line, where we start talking about the equation of a straight line, which is a little more detail in terms of describing a line. But even before we talk about the equation of a straight line, it is absolutely important that you get a firm grasp of the concept of the gradient and the mechanics of calculating the gradient. Once you can do that, you're ready now to move on to the next step.